Okay, so consequences of inflammation on the immune system. So let's go back to our chart. So this is why we use this all the time. So here we've got infection creating and driving the inflammatory oxidative immune response here. We know that we should have an innate immune system which should be overfunctioning to kill the infection. But if it's underfunctioning, it won't kill the infection, and then we'll end up with a compromised Th1-Th2 ratio. When the Th1 goes down, the Th2 goes up, and up goes the Th17, which then further drives it. We also know that we've got all these others, dysbiosis, hypoxia, etc., which all link in to driving the inflammatory process. When we have this cursed high Th2 in ratio to Th1, this stimulates the production of more B cells or antibodies, which then start attacking other tissues, creating allergies like asthma, sinusitis, hollow tube infections like upper respiratory tracts, etc. So let's now fill in the little details in here. So let's start with infection. Infection is the main driver of inflammation. So we've got now the innate immune system. Reduced innate immune system lowers the Th1 status. Low Th1 status drives and increases the Th2 populations, so increases that. Th2 then further dampens the Th1. So as you go up like that, the higher this goes, the lower this one goes. So higher Th17 activity drives the tissue destruction in autoimmunity. So here we see the innate system. So low Th1 status increases vulnerability to infections, and the infection is the main driver. And then dysbiosis, low Th1 status allows dysbiosis to flourish because we're not actually killing off the bad microbes. So you see that's the sort of filling in the gaps there. So chronic infection drives the inflammatory process. Reduced innate immunity, we've just covered or just spoken about that. So Th2, when it's up, tends to lead towards upper respiratory tract infections, sinusitis, and low Th1 maintains the vulnerability to intracellular infections. Now, essential to address hollow space pathogens. These are in anywhere where there's cavities. So this would be the sinuses, the bladder, the intestine, the vagina, etc. So it's essential to address these hollow space pathogens. Hollow space chronic pathogen burden leads to persistent Th17 responses and autoimmune destruction. I think you could add there perhaps chronic dental foci, like a chronic abscess in the tooth, infection in the tooth, tonsils would be counted as hollow tubes, appendicitis would be hollow tubes. So anywhere where there's a festering infection over a period of time would be classical with this. So around 70% of the immune system we know is localized in the gastrointestinal tract, with the mucosa having around 200 times the surface area of the skin. So Th17 drives the destructive process. Here we got researchers identify immune culprits linked to inflammation and bone loss in gum disease, healthy teeth, gum, and you see here we got healthy bacteria living in the base of the tooth there in the gum, and then we get unhealthy bacteria that get in there, the gum receding, severe tissue inflammation and receding of the gum, and then I've noticed Th17 cells migrating in there and then eroding the bone. So then we get effectively osteoporosis of the jaw. Some people would say, in fact, when you get receding gums, and that's the first sign of osteoporosis with a person. And it's interesting because some of the medication that is prescribed for osteoporosis actually drives the process and the gums recede, and dentists pick out this particular type of medication very quickly, and because the gums are deteriorating and the teeth are falling out. So function of Th17, subset of pro-inflammatory T cells related to T regulatory cells. So essential nutrients for dealing with autoimmune issues. We've looked at specific ones for increasing and decreasing Th1, Th2, but nutritional remedies that we may consider when we're using Th17 as the marker. So essential fatty acids have big anti-inflammatory properties. So we know that prostaglandins 1 and 3 are anti-inflammatory. Prostaglandins 2, which is derived from arachidonic acid, is pro-inflammatory. So the omega-6 oils like borage, evening primrose oil, blackcurrant seed oil, these are omega-6 which are rich in GLA, may be required. We don't often prescribe omega-6. We find that people seem to get enough omega-6 oils in their diet. Whether it's the right type and the good oil, I don't know. But we don't find too many, but I don't prescribe too many, but it does come up from now and again. Omega-3, which is the fish oil one, is a rich source, of course, of DHA and EPA. But some people can't take the omega-3, but they need the DHA, which is, again, the active form of omega-3. It's made from algae, from freshwater algae. If you puncture the capsule, it smells of fish, but it's not fish, it's from algae. In fact, it's what the fish swallow, is the algae or plankton when they're swimming around. And then they eat the omega-3 oils. They don't actually make it, but they need it because it has a high melting point of minus 15 degrees centigrade, which keeps the fish flexible in the North Sea and the cold waters. So the colder the water, the greater the amount of omega-3 oils. This is why if you have trout, which is a freshwater fish, it won't have the high level of the omega-3. You've got to have the deep sea. The deeper the sea, the greater the omega-3. And DHA is important here. Now DHA is the richest oil in the brain. It's also in the gonads, the adrenals, and the back of the eye. Particularly, these are places where you'll find if you've got DHA deficiency, it will be the first places to spot it. So DHA is a very important omega-3 oil, as is EPA, which is anti-inflammatory, improves the viscosity, lowers the viscosity, improves the circulation, stops the platelets from clumping together. So people who've got cold hands and feet tend to respond to the fish oil with the EPA. Other people need specifically the DHA, and that's of course better for vegetarians as well because it's not of any fish. Sometimes people need a mixture of the 3 and the 6, we found. This is quite a popular oil. If you don't test with the 2 sometimes together, you don't find it. So omega-3 6 in a base of omega-9, which is a bit of sunflower in there, but it's mostly the 3 and 6 together which seems to be important. So test the person with omega-6, omega-3 and omega-3 6 and 9. Flaxseed oil, which is a rich source of alpha-levulinic acid, and that acid may be required. It's an essential fatty acid that the body can't make. It has to get some food, and flaxseed and hemp seed are rich sources of that. Wheat germ oil I've mentioned over the last couple of days, very, very important, very great source of vitamin E, and more specifically it's of beta-carotene, beta-tocopherol, and not so much of alpha-tocopherol. Now there's 4 types of tocopherol, and I'm going to talk about that in another seminar. And each tocopherol seems to have different cell membranes and things that it protects. So wheat germ oil is an excellent source of vitamin E. Always think about wheat germ oil, remember, for people who've got gluten sensitivity. Sensitive to wheat is because they're eating wheat, which is devoid of the wheat germ. Black cumin seed oil is a wonderful oil, combining omega-3, 6, and 9. Sea buckthorn has, of course, omega-7 oil as well, which is good for all the tubes. Microbiome manipulation. Could fibre-rich muesli help control arthritis and other autoimmune problems? So here we're looking at fibre along with inulin to stimulate the probiotics. Minerals involved with autoimmune, again, possibly those affected by vitamin D. So calcium, magnesium, selenium, because of its effect with the inhibiting immune, and of course zinc. So autoimmune problems could show mineral deficiencies, and if they did, it would probably be those. But the big ones, of course, seems to be this regulation between A and D, because both of these are working on the immune system. and both are important, particularly in the winter months. So if we have a look at A first, in the last module we looked at, if you remember, arsenic and mercury, and here we see arsenic and mercury inhibiting the dioxygenase enzyme here, which converts beta-carotene into all-trans retinal, or which is otherwise the visual pigment. So we normally get vitamin A from our diet, livers and particularly fish livers, but all livers will store vitamin A from the diet, and it usually comes in food associated with within fats or oils, so it comes as retinol palmitate, which is a carbon-16 fatty acid. So that's the usual how it prepares from the food. The small intestine then breaks the palmitic away, and the active form here, or the true vitamin A, is retinol. So this is what they use as retinol units, and this will then become dehydrogenated, in other words have a hydrogen removed, to make all-trans retinal, which is the visual pigment in the back of the eye. So this is the part in the back of the eye which we use to actually send the information to the optic nerve to vision, to see. Now this then crosses over in the eyes to the 11 cis retinal, which is what does the transfer through the opsin to stimulate the optic nerve there. Now, in most of us, we can convert carotenoids directly through to the all-trans retinal as an alternative if we don't have any A in the diet. But there are some people who this dioxygenase enzyme genetically is not functioning as well as it should do, and in those cases they probably need to take the vitamin A because they can't convert carotenoids, so they will get a decrease in the visual pigment. That means they're not seeing in the way that they should see, and if you ask these people, you know, how their vision is, they say, well, it's not as good as what it used to be, and they very soon have to start wearing glasses and things. So vitamin, all-trans retinal, or vitamin A in the active form, will then convert with retinaldehyde dehydrogenase, this other enzyme which makes all-trans retinoic acid, which is an aldehyde here. And this is involved with bone and teeth, the immune system, epithelial integrity, gene transcription, skin, cellular health, particularly the embryo, reproduction and hemopoiesis, in other words, the production of the blood cells. So it's all involved with a lot of important areas in the body. And these are called retinol receptors, and they're mainly on the nuclear membrane, the nuclear cell membrane. So we switch these retinoid receptors on and off, and there's hundreds of different genes that correspond or respond to this. So retinol and all-trans retinol retinoic acid is very, very important part of essential for the immune system. So vitamin A in the form of retinoic acid plays an important role in gene transcription. Once retinol has been taken up by the cell, it can be oxidized to retinal or retinaldehyde by retinal dehydrogenase, and then further oxidized to retinoic acid, which is tightly regulated due to the activity of the ligand for the nuclear receptors. So here we see the vitamin effects on the immune system of vitamin A and D take central stage here. So vitamin D. So on the weather forecast yesterday, it was supposed to be a nice day, really hot day today, but it's cloudy by the looks of it. But they said on the news yesterday when I was watching on the weather that beware of the midday sun because the sun will be dead above you. And in fact, it wasn't dead above because it gets dead above you when you get to the tropics, and especially on the equator at the midday sun. But I don't think ours ever normally gets dead above. It'll be quite high. And when we had the coffee break, I was interested because the shadow was only about 2 foot long. So it's pretty high out that one. And if you remember, you make D when your shadow is shorter than your own height. So if you're 6 foot in height and your shadow is longer than 6 foot, you won't make vitamin D, because that means that the sun is lower than 45 degrees and you need at least 290 nanometers of the wavelength to make the D as it hits the skin and converts the cholesterol under the skin into cholecalciferol, or vitamin D. So what we know is that cholecalciferol is made basically from cholesterol underneath the skin at 290 nanometers. We also get vitamin D in our diet, but it's like vitamin A, it's not easy to get. And this is what they found 50, 70 years ago. By feeding fish liver oil to children particularly, it helped to boost it up. When you now look at the sort of foods that contain vitamin A and vitamin D, there's very few. You know, vitamin D we should get from the sunshine predominantly, and vitamin A we should get by eating offal and liver and things like that. A lot of food say it contains vitamin A, but it doesn't, because A is only in animal food. It's not in plant. So anything which is a plant does not contain vitamin A. It contains carotenoids, and providing you can convert, it's okay. But if you're one of those unfortunate people who's got poor expression of that gene, you then can't convert, and then you need to actually take some form of oil with the vitamin A in. But good liver is a good source of A and D and offal, but the body stores both those fat-soluble vitamins along with E and K in the liver. So we know in the endoplasmic reticulum we oxidize cholesterol at the 25 position, and this is then called the 25 cholecalciferol, which is the stored form in the liver and the muscles and the fat. And this is what we store for the winter time. So we should be now going out in our summertime creating the D so we can start to store that. And that store, which perhaps has a half-life of only about 6 to 8 weeks. So in 3 months, we'll be really low down in our D if we don't keep topping it up. Now that D then further hydroxylates on the 1 position to create or form the 125, which is the main one which regulates blood calcium level. That's the one that occurs, this pathway here, in the kidney, and it occurs in the mitochondria of the kidney here, and is regulated by parathyroid hormone, and it regulates blood calcium, muscle and bone as a result, whereas the so-called, in many books, the inert form is the 24-25 cholecalciferol. So it's like a switch again here. And this one is more involved with the immune system. So we have the immune modulation effect of the 24-25, prevention of autoimmune diseases. So this is the one primarily that we need when we've got an autoimmune response. Prevents infections, regulates cell growth in cancer prevention, improves mental health, regulation of blood pressure, and just generally is anti-inflammatory. So if we switch this one off, this enzyme here becomes inhibited. It pushes it into this one, which increases the blood calcium, shuts down the, increases the absorption of calcium, shuts down the excretion of calcium, and out goes your calcium, and into the tissue it goes. But the problem is, where does the calcium come from? It comes from your bones and your teeth. So you're elevating your blood calcium, which will calcify you, but it's coming out of your bones as a consequence. So we find that the vast majority of people have this enzyme works all right here, but they are low in this one. So this one means that you're weakened to calcium because you're too high, and this one is the one where we need to stimulate, and this one is produced mainly in the prostate, or let's say it's got receptors on the prostate gland, testes, brain, skin, breast, colon, lungs, heart, immune cells, and is inhibited by these toxic metals. So high build-up of these toxic metals may drive the vitamin D production into this way, where up goes the calcium level and you turn to stone. Basically you bung up, your elastin perishes, your joints perish, etc. Now there's a third type of activated form when the 125 and the 24-25 come together, and this is called the 124-25. So the 124-25, or is otherwise known as activator X, which was first talked about by Weston Price back in the 1930s and 40s, but he thought it was vitamin, or they thought it was vitamin K2, but it's not. It's actually the 124-25 cholecalciferol, which is the main hormone modulator. This is the main one. It's very similar to steroid rings, and it's the main hormone modulator of the steroid hormones. So this is the one where you get the response when you've got hormone issues, steroid hormones with PMT, and menopausal symptoms, prostatic problems and so on. It's this one which you need to activate. So this one can be stimulated by the various nutrients here, and also it can be stimulated in some people by vitamin K2. But a lot of it depends upon the cofactors, the magnesium, the zinc, the iodines, etc. And these are all present in base oils. So some oils contain these substances naturally. We find that black cumin seed oil, apricot kernel seed oil are all things that contain these trace minerals which activates this pathway. So the vitamin D receptor, the VDR, may be involved in cell proliferation and differentiation. Vitamin D affects the immune system, and the VDRs are expressed in several white cells, including the monocytes and the T cells and the B cells. In vitro, vitamin D increases the expression of a series of hormones like tyrosine hydroxylase, a gene in the adrenal medulla cells, and affects the synthesis of neurotrophic factors, nitric oxide and glutathione. So here we may find that vitamin D stimulates neurotrophic factors, in other words, helps to recover the brain. So putting the TH1, TH2 modulating compounds together, we see here we've got the A and the E, and then the D in the essential fatty acids. We've shown that slide a little bit before. So just going back to that one. So testing for autoimmunity. TH1, TH2 status is TH1 down, TH2 up. TH17, which is what I would do first of all, it does the person weakened TH. Then we can look for genetic involvements with the FOXP gene, transforming growth factor, and the STAT genes. Test for allergy, immunoglobulin E, G, and M. Test for platelet activating factor for inflammation and NF-kappa B. So just to finish off, I just want to show you more of a physical approach to here from my friend Eric Perotti. Specific muscle to organ associations have been identified with the infraspinatus. So we talked about that earlier today, wasn't it, with Wally Schmidt and his work with the thymus, his infraspinatus, as being specific to the thymus gland and generally indicative of immune function. Other authors like Portelli and Marciano have cited the mid-deltoid also as significant thymus gland problems. In Eric Perotti's experience, in almost all cases, neither the infraspinatus nor the mid-deltoid have ever shown to be inhibited in the clear, as we would expect with obvious immune dysfunction. However, a challenge to the area of the thymus gland by a firm but gentle striking of the mid-body of the sternum with the lateral edge of the closed fist over 4 or 5 repetitions elicited an unusual and consistently reproducible response on patients with T-cell dysfunction. So you find the thymus gland, which is just underneath the angle of Louis or the manubrial sternum, and you give it a firm tap 5 or 6 times, and then you start to see the weakness of the infraspinatus or the mid-deltoid occur. So what he found was bilateral inhibition of infraspinatus, so out there, infraspinatus, or bilateral inhibition of the deltoid muscles. Cross-checking with specific cytokine biomarkers found the following patterns. Bilateral infraspinatus inhibition correlated with the TH2 excess. So TH2 is what's driving that TH17 and the pro-inflammatory. So when you get a bilateral infraspinatus, you know then that you've got probably an autoimmune response. Okay, so this is quite important because often when we test people, we find infraspinatus unilaterally weak. Okay, but if you find it bilaterally weak, this is probably more indication you're going to find an autoimmune. So bilateral mid-deltoid inhibition correlates with the TH1 excess, which is probably why we don't find that very often. And when I tested this, I found that I was looking when we got for the first time we got TH17 as a test biomarker. I was looking for muscles associated with that, and we found it was the posterior deltoid inhibition. In other words, a weak posterior deltoid muscle indicated a TH17 excess, which we find then with all autoimmune problems. So in Eric Perotti's case, he found the resultant inhibition, once initiated, persisted for quite some time after the challenge on there, and the benefit of challenging specific nutrients, botanicals and other therapeutic aids necessary for successful treatment of the dysfunction.